So in this video, I will be discussing the most frequently asked question on multi-threading. Okay, so I will not be covering all the topics, but I will cover one topic which is asked like to freshers or to experienced. So the topic is atomicity. So how many of you know what is atomicity? Okay, how atomicity works in multi-threaded environment. So that is very crucial thing, and they can directly ask you in interview, what is atomic integer? What is atomic long? So how will you answer those type of questions? Okay, so it was asked to me as well as to some of my friends, so that's why I wanted to discuss with you this important topic, and I have used this in my project as well. In my multi-threading project, I have made use of this class, atomic long, atomic integer. These classes I have made use of, so that's why I'm going ahead and will discuss with you this important topic. So let's get started. I hope you can see my PPT now. So I've created a small PPT. I will not go much into theory part. So I just wanted to give you the background of it, like why atomicity came into picture and why we have to learn atomicity. Okay. So atomicity generally works with concurrency. Okay. So whenever there is like concurrent threads trying to access the resource at the same time, so at that point of time, we can get some data inconsistency. So I will show you via code like how data inconsistency may occur. Then you will get some idea on that. So as of now, just stick to the theory part for just some time, and then I will go back to the coding part. So it's basically worked with concurrent programming. So if there are more than one thread trying to acquire the resource, so let's suppose I have initialized one variable, let's suppose b to 0. Okay, so now two threads are coming. So first thread is trying to increase or decrease that value by 1 or 2. Okay, so now how second thread or third thread will be able to know like what value the first thread has incremented for that a variable. How will it be possible for other threads to know? So basically this you can implement via synchronization as well. You can synchronize a method, or you can synchronize that particular method and you can use that field and increment it. That way also you can do. You can do with the help of locking mechanism as well. But those all things requires a lot of complexity. Okay, we have to implement a lot of things. We have to write specific synchronized method, and improper synchronization may lead to deadlock situation as well. So we have to implement synchronization in such a way that it should not lead to any kind of deadlock situation. Okay, so that's why to make it much more simpler and easy to use, specific for reference variable, for that we have to make use of atomicity concept. So whenever you are making a variable atomic, so for every primitive types or the wrapper class types, let's suppose integer, long, okay, float, for that there is a certain concurrent class available. If I'm taking long, so there is atomic long. If there is integer, there is atomic integer. So what's the advantage of using atomic integer or atomic long? So basically in this, it's already giving you the benefits of features of concurrency. So within that only the synchronization concept is there. So whenever you are making use of atomic integer, so internally it is making use of synchronization. So basically you don't need to explicitly write a method with synchronized keyword like public synchronized void test or doing some logic you have written on that. So you don't have to create any separate method for that. Automatically, if you are writing atomic integer or atomic long, internally it will do the synchronization for us. So internally it will make our resources thread safe. So that's why atomicity is very much crucial and important. Okay, but that doesn't mean that you will not implement multi-threading properly. It will just give you the synchronization concept. So later part of logic you have to implement. But if you are making use of atomic, it will give you the concept of synchronization internally implemented as well as the volatile feature. So if you are not aware of volatile, so let me tell you, volatile is a keyword which you have mostly used in singleton classes as well. So if you remember multi-threaded singleton classes, if you have not gone through that video, you can go through my video in the second part of singleton design pattern. I have explained you like what's the importance of using volatile keyword in that reference variable. So basically each thread maintains its own thread stack. Okay, so if you are starting one thread, it will start its own thread stack. When second thread is starting, it will start its own thread stack. Third thread will start its own thread stack. So no thread will interfere with each other. But what will happen if you are not making use of volatile? So each and every thread will update the data or the field instance values to its own specific cache memory. Okay, so every thread stack has its own cache memory. So let's suppose thread 1 has came and it has updated a field to 2 from 0, but other threads will not be notified what thread 1 has modified. This will be a big problem. So to resolve this issue, so that the changes are there in the main memory, and if changes are there in the main memory, then other threads can be able to see like what first thread or second thread has made modification on that reference variable. So to resolve this issue, multi-threading has come up with volatile feature in concurrency. So whenever you are making use of volatile keyword, their visibility will get guaranteed, because any thread is making change to any of the field, it will be visible to all the threads because it is there in the main memory. So that is the importance of volatile keyword. So this volatile feature and synchronization feature is imbibed into this concept of atomicity. So that's why it is becoming more and more important for the interviewers as well as while you are implementing multi-threading in your project. So without any delay, let's understand through code as well. So before going that, let's see like what all typical methods are present which we can make use of using atomicity. So these are some of the classes that are present in atomic class, like AtomicInteger, atomic long, atomic boolean, atomic reference. So it's similar to integer, long, boolean, wrapper classes. So those integer, long, you could have made use of it directly, but you have to explicitly make use of volatile keyword or synchronization of the method. To not go into that much complexity, we can simply make use of atomic keywords. Okay, so you will be having both the features together. Okay, so these are some of the common things that we have to understand. So these object of these classes basically represents atomic variables of int, long, boolean, and reference. Okay, so these are some of the most commonly used, and I have basically used add and get, decrement and get. These are most commonly used, and set and get also needs to be understood. So these are just like set get is just like getter and setter. You are setting some fields in entity class or DTO class. Similarly, you are setting the value. So you are setting a value to a setter data. Get means you are getting the current value. Add and get. So what it will do, atomicity means atomically, it is the smallest part. Okay, so it will acquire the resource. So if one thread has acquired a resource, okay, so no other thread can come and interrupt in between, so that there will be a proper consistency of data in the output. Okay, so it will add the value to the current value. So during that updation, if you are making use of normal integer, then what may happen? So other threads can interrupt in between and add some data onto it. Okay, so it will give me inconsistent output. So it's very vague. So we will not be relying on that. No client will be able to rely on those logics. So to maintain the consistency across all the application, we have to make use of atomic data, atomic classes. Okay, so similarly there's decrement and get. So it will decrement by 1 the data and it will add it to the current value. So these are the important methods that we are most commonly use. If you are not using first and second also, then third and fourth one, add and get and decrement and get. These two I have personally used in my project. So this is very much important. Yeah, so this part with respect to slide is done. So now let's jump back to the code and let's see how we can implement atomicity and the importance of it. And I will ask you a few questions on the output as well. So if you can observe here, so I have created one class called atomic class. Okay, I have created one counter and initialized it to 0. Okay, I have created one synchronized method over here. Okay, I've created one synchronized method and I've incremented the counter by 1. I have not created any other class. I'm just making change in one single class only. So basically there are like multiple threads I have made use of, like atomic class, atomic counter. Then I'm creating one thread reference. I'm creating new thread, and I have not created any class that extends thread class or implements runnable interface. These two are basic ways to create a thread class. So all those logics I have written over here only via lambda expression. So lambda expression gives us that flexibility to write the logic at that point itself. You don't have to write in a separate class. That is now optional after Java 8. I have written the job over here. I've written the logic, and for thread T2, same thing I have done. I have run the loop from 0 to 2000. So here it is calling atomic counter dot increment. So I am calling this method over here, which is increasing the counter value by 1. This is for first thread, and it will do the increment 2000 times. That means it's starting from 0 to 1999. It will go 2000 times. Similarly, I am doing for thread 2. Similarly, I am doing for thread 3. Okay, so now I am starting all the 3 threads. So can you tell me what will be the final value of this get count method? So atomic counter is the object of this atomic class, which is the current class. and I'm calling get count method over here. So if you observe, get count method is here, which is returning me the count value basically. So after running all these three threads, so what are you thinking, like what can be the output for this code as of now? I am just starting the three threads and I've written this logic. Just think on it once. I will give you 5 seconds. I hope you have guessed the output. So you might be thinking that output can be 6,000 because I am running all the three threads and internally it is incrementing the counter by 1. Here it is incrementing the counter by 1. So you might be thinking that for first loop it will run 2000, then 2000, then 2000. So it will give me output as 6,000. You might be thinking like that, right? So let me show you the output. Then you can understand like what can be the output. Let me run it. So here you can understand the counter value is coming as 731. So you will ask me like, Devjit, how can it be possible? Counter value, how it came as 731? There is no relation, right? There is no mathematical calculation happening. Just it's incrementing the counter. So can you be sure that answer will be 731 only? Let's run it again. It's showing 255. Okay. Now let's run it again. Now counter value is showing 0. So now what you have observed over here? If you will observe closely, so random value will be lying from 0 to 6,000. The loop is running explicitly from 0 to 2000 for 3 threads. So any random value from 0 to 6,000 will come. So why it is happening like that? Why there is no consistency? Output should be 6,000, right? So why it is not happening like that? So basically we have to understand there is no proper synchronization happening over here. So any thread is trying to acquire the lock over other thread processes. Okay, so this is the process. This first loop is happening for the process thread T1. Second loop is going on with a task for thread T2. So there is no proper synchronization concept you have applied. There is no synchronization method, or you have not made any atomic classes. So what will happen? When thread T1 is executing, so whenever a server start, how many threads are getting created? Can you tell me? If I run this class, if I'm trying to run this class, then how many threads are getting created? So if you observe, I am running main method. So main is also one of the thread. So first thread is main thread. Second thread is this one, T1. Third thread is T2. Fourth thread is T3. So basically it's 3 plus 1, 4 threads are getting created over here. Okay. So what will happen? If there is no proper synchronization, so first thread, let's suppose, has incremented up to 200, then second thread also will try to interrupt here and try to do some modification. So it will be data inconsistency. So all three threads are parallelly running. Okay, so it will give you a random output between 0 to 6,000. So I need to make it run consistently, okay, with proper synchronization, so that there is no data inconsistency output will at the output I'm getting. Okay, so how can you make it possible? So there is one method we have to make use of, that is join method. Now we will be able to understand the importance of join method. So now let's do T1 dot join, T2 dot join, T3 dot join. So if I'm not writing join method, then what is happening, guys? So basically it is running the threads, it's incrementing it, but it is not blocking the main thread. So once the main thread is executing, so JVM is taking control of it, right? So in JVM there is something called as thread scheduler. So thread scheduler will decide like which thread will be given the more priority over here. So if all the three threads are running parallelly, then we are not blocking main thread, right? So main thread can what main thread can do, so at some point of time, thread scheduler can provide the higher priority to main thread. Then what will happen over here? Main thread can come to this line number 44 and it may print the count. So at any point of time when JVM is assigning the priority to main thread will be coming to 44 line and it will print me the counter, whatever will be the counter at that point of time. It depends upon thread scheduler and JVM. We are not we are not knowing on that aspect. So what we have to do, we have to block the main thread until and unless all three threads, all these given three threads are completed. Then only we have to provide the permission to main thread to execute the last line. Okay, then only we will be getting the consistent output. So this is the advantage of using join method. So whenever you are using join, t1.join, so other threads will be waiting till thread T1's task is completed. So once T1 task is over, then T2.join we are running. So T2 will be executing its task now, and then after that T3 will be starting. So it will be like a proper sequencing, in a proper sequence order it will follow, so that we'll be getting the consistent output as a result. Okay, so let me run it so we will get to see like what is actually happening. See, the counter value is coming as 6,000, which is the actual output. 2,000 plus 2,000 plus 2,000, which is 6,000. Let me run it multiple times to see like whether the output is getting changed or not. You might be thinking like it's multi-threading, it may change its data. So if I run it however how many times possible, it will give me the same output. See, I have run it already 3 times. Yeah, it's 4 times I have run. 4 times is giving me the same output. That means we are getting consistent result. So how come it is happening? It is happening with the help of join method. So now let's understand the importance of atomicity. So what we can do here, so basically we are doing the counter of it. Okay, so basically what we can do over here, we can have atomic class. So if I'm making use of atomic classes, then we don't need this synchronized keywords. Without making use of synchronization, still it will work fine, because I've already told you atomicity contains the benefits and features of volatility, volatile keyword, and synchronization concept. So let me create an object of atomic class, atomic integer. So it is present in java.util.concurrent.atomic package. So there is a separate package, java.util.concurrent package. Within that, there are multiple java.util.concurrent.atomic package. Within that, all atomic classes you will get to see: atomic long, atomic integer, atomic reference, atomic boolean, everything related to atomic you will get to see. So here you can refer to for Java doc to understand the logic, like how and all it is written. Okay, so as of now I'm not going in depth onto it. So let's understand atomic integer. Okay, atomic integer counter equal to new atomic integer. I am giving it some default value over here. Okay, so now I'm removing synchronized keyword. Okay, so now what we are doing over here, so there is some inbuilt method which I have told you, which I can make use of. So let's understand that. So counter dot increment and get. This method I've already told you, increment and get, decrement and get, these two methods are present, right? So I'm making use of that method only. So we are doing increment, so I am writing increment and get. Here we are getting data, so we just have to write get method. So here we can return counter dot get. Directly we can make use of get method. So here if you observed, I have removed the synchronized keyword from the method. So now method level is not synchronized. So let's see what will happen. So I have already have the join method, start method, everything is in place. So now let's run the code. See, counter value is saying as 6,000. Let me run it again. Counter value is 6,000. Let me run it again. Yeah, counter value is showing as 6,000. So here you can understand, however how many times you run, it will show you 6,000 only. But if you are not using atomic class, then it will give you inconsistent data or random data between 0 to 6,000. So that is actually wrong result. So to get proper output, to get consistent result, we have to make use of atomic integer. So there is no compulsion. If you don't want to use, you can anyway skip it, but you have to implement synchronization method. You have to add the volatility concept, volatile keyword you have to add. So those things you have to add. So why to increase the complexity of the code? Try to keep it simple, right? So if you are making use of atomic integer, both feature you will get it inbuilt. So you don't have to explicitly write anything with respect to concurrency. So this is the advantage of making use of atomic integer or atomic long. You can try to run the code by yourself, then you will get the glimpse of it, like how actually it is internally working. And this class, if you go through, there is a specific Java doc with, you can see AtomicInteger, which extends number. Okay, so it's a number. Okay, number is a class from java.lang package, and which implements serializable interface. So serializable is a marker interface basically, which don't have any method body. Okay, so in this also, there are a lot of questions can be asked, like what is marker interface? What's the importance of marker interface if you don't have any method? What's the importance of this serial version UID? Okay, so this is very important concept. So serial version UID is why required basically, because if you are doing serialization, so there is one serial version ID gets created. So when the Java object gets converted into stream of bytes which are being sent over network to get converted to some data onto file, to write onto file or database, then serialization is happening. Deserialization happens when we are deserializing the object from the file or database. So while doing deserialization, there should be some key, right? There should be some ID. With the help of it, it will match, like whatever data we have passed with that ID. Is it the same data you are getting it from DB or file? So there is serial version UID which actually tracks that, whether that conversion ID is same from both the side or not. So if you are not overriding serial version UID, then there is high chance that it will give different serial version IDs and it will not deserialize properly. So if you will see my how to break singleton design pattern through deserialization process, you will get the idea over there, the importance of serialization and serial version UID. Okay, so I will not go into that. You can see the video. So there is a lot of things which is implemented. There is a constructor with initial value. There is a default constructor. There is a get method which will just return the value. Okay. There is set method. Lazy set method is also there. A get and set. Okay. Compare and set. There are a lot of methods you can see over here. Okay. Get and increment. Okay. Get and decrement. Okay, you can just, so we have made use of this method, increment and get. So what is written? Atomically increment the current value with memory as specified by this. So these are the things that you have to go through. Okay, this are the given methods which are present in this class. So don't have to write specific logic for that. You just have to call this method. Okay, I hope you got the clarity on this. So these are the things that we can implement. So don't have to add synchronization directly. It will consider volatile as well as synchronization concept within atomic class. So these are the things. So you can go through this code and you can try to implement it in your IDE. You will get a clarity on it, like how atomicity is working internally. So I've discussed everything. So if you are being asked any question on atomicity now, I think you will be good to go. So I will be creating series of tutorial videos on multi-threading concepts similar to a class which are commonly asked in interviews. So put it down in a comment box. How was this video? I got valuable information like that. So I will get the motivation. Okay. And I will create a series on multi-threading, because if your experience is getting more and more in IT sector, no, so they will focus more upon these concepts only. How multi-threading you have used in your project. And 50% questions will be on multi-threading, collections, data structures, Kafka, Spring Boot projects, design pattern in microservices. So all type of questions will be revolving around these concepts only. So if you are preparing on this, then you are good to go. So I hope you have learned and understood it. If you have learned it, please like, share and subscribe this channel, and we will be making these type of videos again and again. So stay healthy, stay wise. Bye-bye. I provide consultation calls or one-on-one session calls or one-on-one mock interview sessions for all of you, so that you can ace ahead in your IT interviews, okay, and crack the big service based or big product based organization. So how can you do that? So I am taking mock interview sessions. So you can go ahead in the description box below, book a call with me, okay, one-on-one session call, and we'll be having a one-on-one conversation.